Hi, my name's Peter Cooper. I am the head of data for Asia Pacific for Greenplum. It's really sad that we can't meet up in person. I know we've had some great summits in previous years, and I've really enjoyed, the coffee breaks and all of the good snacks that we have, particularly when we're doing one of these up in Asia. But there's a lot going on in Greenplum, and we thought it was worthwhile taking some time to connect with everyone, even though it's only virtually. We have, during the presentations, we will have people monitoring all of the chats. So please, if you have any questions, put them in the chat window and we'll try and answer them in the chat during the call or at the end of each session. Now, before we get started, I'd really like to get to know a bit more about each one of you. So perhaps we can just start out with a poll. How long have you known Greenplum? Less than a year, less than 5 years, less than 10 years, or more than 10 years? Okay, we're filling up nicely, 32 out of 48. Come on, don't be shy. I think we're getting some shy people up there now, so we might see if we can make it to 40. Okay, so Hale, if we close the poll. Right, so we've got an interesting mix of people. We've got a bunch of people who have known Greenplum for less than a year, but a healthy number, 11 people, less than 5 years, and then a handful in the 10 years and over 10 years mark. That's great. I have been with Greenplum for a number of years. It's actually my 12th year. And being 12 years, I'm feeling a little nostalgic. So I'd like to sort of take you through a little bit of a journey around how did we get here? Now, where are we and how did we get here? I'll start out at a 30,000 foot view. Right? This diagram is a bit of an eye chart. You're not meant to actually understand everything on the eye chart. This diagram is every product in the Dell technology family. Now, Michael Dell is after world domination. Well, maybe not world domination, but world IT domination. His goal is to have every product that you'll need in order to run your business available from Dell Technologies. And for the record, Greenplum is right there in the middle. So we're up at 30,000 feet. We decided to zoom in a little closer. Michael Dell bought VMware. And VMware's goal is to allow customers to build, run, manage, connect, and protect any app on any cloud on any device. And so everything we do is about this any vision. And you'll hear the any reflected in the presentations that you see today about Greenplum. Now, VMware has been aggressively expanding its portfolio, and part of that expansion was the acquisition of a company called Pivotal. And with the acquisition of Pivotal, VMware created a new division called Tanzu. Now, Tanzu is all about modernizing the way that companies build, run, and manage applications. Applications can both create data and consume data. And the faster you can analyze this data and create new customer experiences or optimize business processes, the faster you pull ahead of the competition. So we create an application, the application creates data, you analyze the data to create a better application, create a new application, and around you go. The faster you can get around that circle, the quicker you'll pull ahead of your competition. Today's presentation is focused on one of these products, Greenplum, just there in the middle again. So what is Greenplum? Greenplum is an open source scalable MPP version of Postgres, right, with many extra features. Let's analyze this in a little detail. Greenplum is open source. You can go to greenplum.org and download Greenplum and run it for free. Right? Most of our competitors are not open source. Right? We can run anywhere. We run on bare metal, we run in the cloud. A lot of our competition are either restricted to bare metal or is restricted to only cloud. And we are a real database. We have updates, we have indices, we have everything you expect from your traditional data warehousing environments. So we're not a restricted data lake solution. We're actually a full data warehouse. We also have a lot of open extra features. Again, these are open source. You know, our machine learning, our graph, our federated query processing, all open source, available for free. We also have a lot of enterprise features that are available in our commercial version. Things like our text search platform and our advanced monitoring. Today's presentations are going to be focused on these open extra features and these enterprise extra features. So that's where we are. I'd like to spend a little bit of time talking about who we are, because I think it explains, our evolution explains a little bit about us, about why we're special. Greenplum actually started out as a data warehousing product that was focused very much on replacing Teradata. As was 15 years ago, we originally ran on Sun Solaris, on Sun Thumpers, for those of you that remember those machines. There are actually a few customers in Asia Pacific that started out on Thumpers. We attracted the attention of EMC, and EMC said, you guys look like you've got something special, we'd like to buy you. So EMC bought us, and they weren't a big fan of Solaris and Thumpers. So they taught us about Linux and Intel servers. And this really helped us change the total cost of ownership and the openness of our solution. They also taught us a lot about the appliance market and how to optimize hardware for rapid enterprise deployment. In the IT industry, nothing stays the same, and EMC is bought by Dell. And Pivotal is created. Now, Pivotal was all about platform as a service and agile development. This put us on a very different development path, where we were focused on open source software instead of commercial. And we're also focused on the ability to change our product life cycles very, very quickly and develop new features quickly. And from there, Pivotal got bought by VMware, and that's where we are today. VMware is all about virtualization, containerization, and multi-cloud. So we're taking everything that we've learned in the past and we're learning how to do it virtualized, how to do it in containers, how to do it with multi-cloud. All through this exciting journey, our performance and our scalability has continued to grow. This has been a constant for us. Our big systems, we started out at 100 terabytes. We're now running systems that are 2 or 3 petabytes in scale. Our concurrency has gone through the roof. So the whole while we've been learning about the different expertise that our purchasers have brought to us, we've been working on our performance and scalability as well. So over the last 15 years, Greenplum has been the best version of Postgres for BI and analytics at massive scale. We have seen a lot of competitors come and go. Right? You know who they are. But we've stayed, we've evolved, and we've stayed relevant. So that's where we are in the world, and that's how we got here. The rest of this session is going to be a little more Zen. We're going to look at today. How do we get the most out of today? So with that, I am going to hand over to my good friend, Mr. Thomas Boujard.
All right. Hi, everyone. Bear with me for just a second for sharing my screen. If you can stop sharing yours, Peter. Okay. Here we are. Hi, everyone. And for the ones who've just joined us, welcome to the Greenplum APJ Summit. We've just heard a great introduction to Greenplum from Peter Cooper. And in this session, I'm going to be your host for the next 15 minutes. And we're going to look at the deployment options for Greenplum. My name is Thomas Beaujard, and I look after data analytics at VMware for Australia and New Zealand. The title of this session is Greenplum Everywhere. And so what? It sounds a bit like a catchphrase. And we're going to discuss in this presentation, first, the context. We're going to unpack that title, understand what challenges are faced by a decision maker in IT when they need to choose the deployment options for their platform. We're going to look at the different deployment options for Greenplum. And lastly, we'll look at all the benefits. So what about Greenplum? So Greenplum is an analytics platform. It's basically generate business insights in the form of traditional reports, machine learning model prediction, and data products. The way it works is basically it's got data sources upstream and data product downstream. It integrates with data sources, can be structured or unstructured data sources in terms of system of records, system of engagements like CRM, or any other feeds like IoT, logs data, images, voice, data, documents. So that's one big integration point. And then the second integration point is with the data product downstream in terms of integrating with business apps, BI tools, and API. So those two integration points are really important because in today's world, we want things in real time. So latency is important. And there's that concept of data gravity, a term that was first introduced by Dave McCrory around 2010. The idea that data attracts more data as it gets bigger and attracts as well application and services. And it's just hard to move around. So depending on your latency requirement and throughput, we have to think seriously about where to host the data platform. So you've guessed it, the next big question is, where do we host the data platform? Where do we put it? And that's the big question. And the answer is, it depends. There are key considerations to look at. The first consideration, we've just looked at it, is the data source location, can be one. Then the second one is agility. And when we talk about agility, we talk about short-term agility, how easy it is to provision a platform. What about my day-to operation, as well as long-term agility? How about, I want to change IaaS, a few years down the track, how easy it is to move my data platform down the track. And then accordingly, we've got the cost as a key consideration as well. We can have some short-term costs and long-term costs, and some options are going to be very attractive from a short-term perspective and less so from a long-term cost perspective, and vice versa. So it really depends on the IT strategy. It also depends on the benefit realization. Scalability is an important consideration and how quickly we want to be able to scale, how flexible we want that to be. And lastly, the advanced analytics features. So the availability of those features for the platform, because they're required to turn those data sources into insights. The good news is, with VMware and Tanzu Greenplum, there's no need to compromise. We can deploy on any infrastructure, starting with on-premise, on bare metal, regardless of the provider, maybe Dell EMC or others. We can deploy on more advanced platform from Dell technologies such as VxRail on-prem. We can deploy on virtualization, such as vSphere and vSAN. And we can deploy on VMC, so the VMware Cloud on AWS, now as well coming on Microsoft Azure and Google Cloud Platform. And we can deploy on Kubernetes, gives that flexibility from on-prem to cloud, and obviously the public cloud deployments. So we're going to look at public cloud first, because you can go straight away on the public cloud and provision a Greenplum cluster in a few minutes. So let's look at the benefits there. So first of all, Greenplum on cloud basically provides a cloud-native experience with autonomous database operation. You can have a single-click deployment that is automated. You can have self-healing cloud infrastructure underlying. You can do snapshots of your whole database for backups and for disaster recovery. You can have elastic compute and storage independently, and you can also optimize your cost accordingly. And you can have the performance that you're used to on-prem. And this on the marketplace of Amazon Web Services, Microsoft Azure, and Google Cloud Platform. So let's go into the details here. So first, combining the self-healing capability of the public cloud with the high availability HA capability of Greenplum, then we can basically lose a node on a cluster, which may happen, without any downtime to the end users and without any too much trouble to the DBA, which means that the cluster, the service is still on for the end user and the cluster self-healed, which means that the DBA gets his social life back. He doesn't have to connect in the weekend or on Christmas Day when this happens. You can do snapshot of the whole database in a few minutes, and you can restore that. This can be very useful for disaster recovery, and it can happen across regions as well. The data volume under which the platform sits can be expanded from 500 gigabytes to 16 terabytes each. And with GP Grow, we can basically grow the database accordingly without any downtime for the end users. And it's basically an ability to scale the storage without touching the compute. We can automate all the maintenance activity with GP Maintain, and those are really important, such as analyzing the database, vacuuming the tables. And we can manage the full stack of modules that are available on Greenplum. So when you get Greenplum, you get straight away lots of very interesting modules for processing the data, such as machine learning library, Apache Madlib, such as PXF, the extended framework to access different data sources on Greenplum, the command center to monitor your workload, and to do data science modules can by and as optional, and you don't need to. The other very important feature in terms of maintenance is the upgrade capability. The ability to upgrade the platform easily. Thinking about Greenplum, we get a new minor version every month and a new major version about every 18 months or so. These upgrades are very important to benefit from the latest features of Greenplum. Yeah, but sometimes an upgrade can look like a daunting task. Here with the Greenplum on Cloud, we basically tested and automated this for you so that it can happen easily without risk. You can also schedule downtime if you want to reduce or optimize your cost of your IaaS by using GP Power Pause and Resume. And lastly, we provide enhanced data protection policies with Greenplum's own security controls, and we also integrate with a lot of security partners, and that's available on the cloud. So now let's look at on-premise. The first thing to mention here is Greenplum reference architecture. And that's really important because lots of customers, not lots, some customers ask me, what do you recommend we should deploy Greenplum on? And the answer is really, it depends. Again, it's not for us to drive the strategy around what sort of infrastructure should be deployed, but it's really for us to make sure that our solution works well on every infrastructure, and then the rest becomes an IT strategy decision. So what we've done with the reference architecture is that we use the bare metal deployment as a benchmark, and we make sure that every deployment, can basically align to that benchmark. Talking about bare metal specifically on premise, being part of Dell Technologies, we've engineered a solution with Dell EMC that is super optimized in terms of performance and cost. So now let's look at the best of both worlds, hybrid cloud. This undeniably provides the most flexibility. You can start with public cloud, you can start with private cloud, you can have both, and you can change. That's the whole idea. So why Greenplum on VMware? The first reason is it reduces complexity, can simplify operation and maintenance by abstracting the infrastructure layer. We can change infrastructure. That's very flexible. It can be any hardware, it can be private or public cloud, and we can have multiple deployments. And that's super important, especially if you have a shared service and you want to be able to deploy data warehouses consistently to different departments, different line of business. It's really useful in that sense. So to reduce complexity, we've got VM templates. So we basically created a VM of our Greenplum, and it can be deployed anywhere at any size. And it's easy to provision and choose what sort of resources we're going to provide to those VMs. The operation and maintenance is easy, as those VM can be moved around with vMotion from one server to another, from an ESX server to another. And in terms of infrastructure, you can have a fairly traditional infrastructure on-prem with local storage, direct attached storage, dedicated host deployments, so one VM per host. Or you can have more virtualized with Kubernetes on top of vSphere, as well as virtualized storage with vSAN, and virtualized infrastructure, on-prem or on the cloud. So to conclude, VMware Tanzu Greenplum is a state-of-the-art analytics platform, and it's the only open source multi-cloud analytics platform available on the market today. Brings compute to your data, can automate day-to operation independently of your IaaS. You can optimize your short and long-term costs. You can scale with no downtime independently of IaaS. And you've got flexibility of using rich machine learning and artificial intelligence features in database and on the edge. But actually, I haven't talked about that yet because this is the topic of the next sessions with my colleagues. And before I hand over to Suhail to talk about federated queries, I've got a quick question to ask you, and you're going to see the poll survey coming up. Who plans to try Greenplum on bare metal, virtualized platform, container platform, public cloud, and hybrid cloud? And you can select multiple answers. So go for it. So virtualization is leading the way. Waiting to get at least 50% of the votes. Don't be shy, there's no right or wrong answer here.
I will close the polls in about 8 seconds from now. So you still have 5 seconds to respond to the question, to the poll.
Thanks to Hale, and we've reached 50%, which is quite good.
Which is good.
Excellent. Virtualization, that's great to hear. And we believe that's definitely the future in terms of providing the most flexibility. That's great. Thank you very much.
Hello. What is interesting here is like people would really want to see, they want to use container platforms to run their stateful workload. That's very interesting and very important.
Thanks, Suhail. And over to you.
Thank you. All right, let me end the polls. Okay, so can you guys see my screen? Excellent. Good morning, good afternoon, everyone, based on where you have joined us from. My name is Suhail. I look after the Greenplum and Tanzu data in South Asia. I have been with Greenplum / VMware / Pivotal for about 10 years. And I've literally seen how platforms have evolved in the last 10 years. Now, one of the things that we have seen consistently is that enterprises have invested into multiple data platforms. Of course, for multiple different use cases, right? There are data lakes, then there are operational databases, and then there are new gen data platforms, right? And other than that, what we are also seeing, which is quite consistent again, is the fact that, we see different data types, we see different file formats, so we see new gen data lakes where Hadoop used to be the kind of a standard for data lake. Now what we are seeing that the enterprises are looking at cloud-based storages as a ways and means to store and analyze their data. However, one of the things that really happened about 4, 5, or maybe 10 years ago, there was this whole notion around, hey, can I bring this entire data into a single data lake and give access to my data analysts and give access to my data scientists so that they can make sense out of this data? Some of the customers did manage to reach to that maturity with respect to the data lake. However, majority of the customers, to be precise, roughly between 70 to 80% of the customers did not reach to that level because of multiple reasons. Issues with the technology, politics of getting the data from all these sources, and also the latency that is that basically gets created when you start to move the data across. So if you look at the current state of a warehouse or let's say an operational data store, you have ETL pipelines, you have data pipelines, right? You extract the data from all of these sources, which could be an Oracle database or MySQL, or it could be flat files, or it could be straight away from an IoT device, right? You push them into a landing zone, which sometimes can be Hadoop, which could be an ETL tool like Informatica, or it could be like a Spring Cloud data flow type of platforms. You transform them, and you push the final data into the warehouse, and where you have a special dedicated data model, and then you have all of your users accessing that data. This is what is happening since the day of inception of data warehouses, right? And this is where most of you guys today, I'm sure you're using the same approach. So here is an example, right? You have a data analyst or a data scientist who has basically a requirement from the business saying, hey, can you give me the sales report last year versus this year, and as of yesterday? Since majority of the data is already inside the data warehouse, so for a business analyst or for a developer, it's easier to run that report and run that, get the output back to the user. Now, one of the things that, again, we are seeing that the business users are asking more and more, right? The demands are increasing, right? And one of the things that people are starting asking is, hey, can you give me the sales report as of now? Now you can, and if you implement those expensive CDC technology, CDC tools, which will extract your data from all of these source systems, and then there is a bit of a latency as well. Or alternatively, you have an option of using something called the Parallel Extension Framework, or PXF, which is basically Greenplum Query Federation. So what PXF is, it basically provides us a parallel high throughput data access to the external data sources, right? So if I have a Greenplum today, and if I've configured PXF, which is, again, it's a bundled module of Greenplum, so you don't have to separately buy PXF. It's a single part, it's a part of the Greenplum. If I create a PXF and say, hey, Greenplum, can you ask PXF to go and run this query for me on an external data platform? So that's how PXF works, right? So the architecture of PXF is very simple, and we, as Greenplum, we always try to keep the architecture very simple, but under the cover, it's very comprehensive in a way the platform interacts with each other. So what these PXF are, basically, these are a bunch of stateless JVM processes. You don't have to have necessarily a different set of hardware to run this PXF. You install PXF within the Greenplum segment servers. The way it works is user goes to the Greenplum master, says, hey, here is the table, which is maybe an Oracle, right? Then segment servers will send an HTTP request to the PXF modules, and then the PXF module will do the rest, right? It will start to interact with the external sources, and then it will bring the data, whatever relevant data we need for our queries, and then Greenplum can join that data with the data which is inside the Greenplum tables, right? So it gives you a unified access to majority of your data sources. Now let's look at previous example, but in a bit of a complicated way, right? Business users are coming back saying, hey, fantastic, we had this campaign yesterday, and the results that you gave me in the previous report, which was as of yesterday, as of now, it did work well. However, we want to see how did we do, let's say in last 10 years. The challenge in this case is I may not have all of this data inside my warehouse. I may have offloaded this data into a data lake, or I may have offloaded this data into an object store, which it could be like a cloud object store like S3, or a hardware-based S3 storage like ECS, or a software-based S3 storage. So it could be anywhere, right? The other challenge that we may have is this data when I'm, let's say, offloading it onto these data lakes. The file format may be different. It might not be a text file. It might not be a CSV file. Maybe it's an Avro format, or maybe it's a columnar Parquet format. On top of it, maybe let's say the data that we offloaded onto a data lake is compressed, right? Now imagine all of this complexity around, and now you're asking your user, hey, go ahead and run this report for me, right? So one of the options, again, if you go back, is, hey, let's ETL entire data in. I don't know whether it's 100 terabytes, 200 terabytes. I do not know if I have enough space. Or alternatively, since this is one-off reports, one-off use cases, or maybe I don't have to run these reports every 5 hours or every 10 hours. Maybe I run it once in a day or twice a day. And yeah, that's it. And I give the results back to the user. So again, the answer to this complex request is PXF. So PXF has built in multiple different profiles, and each profile has, let's say there is a profile for S3, then there is a profile for S3 Parquet, and there is a profile for JSON. So all of these profiles are actually bundled in for you guys to consume. And again, in terms of the complexity, we will, in the subsequent slides, we will talk about how easy or how hard it is to use data federation or federation queries, or PXF, you may want to call it, in Greenplum. Now, as we did talk about, hey, what if I create an ETL job? You may not have enough space. You may not have enough time. ETL is a time-consuming process, and especially when you're looking at big volumes of data. So federation gives us rapid access to the data. You may not need a transformation since it's a one-off requirement, and there is literally a zero latency. The moment I run a query on Greenplum using PXF, it will actually exactly at the same time it will go and start talking to the external databases. Now, the moment you talk about JVMs, the moment you talk about stateless processes and all, people do get a bit finicky. Hey, does that mean my database developer need to learn Java? They need to learn all of these? The answer is no. The way we expose the data from the external sources is through an external table, and the external table is almost as good as a regular table. It's just that it's a metadata stored inside Greenplum. The rest of the data, the actual data is outside Greenplum. So when you define a PXF table, you say, hey, here is the table definition. Here are the attributes. Here is where the data is stored. In this case, I'm actually accessing a Hadoop cluster, which is probably the server IP host name is called Cloudera, and the file format in this case is Parquet. That's what I need to tell the Greenplum. Say, hey, here is this table. Just go ahead and create it for me, and at the same time, run the query on this. Now, when we talk about federation, one of the important concepts of a federation is performance. Right now, we are talking about big data. We are talking about large volumes of data. So what happens, if I'm accessing, let's say, a 50 GB of data, or 100 GB of data, or 3 terabytes of data? What kind of optimization do we have inside the PXF that allows users to have a good performance with respect to the a reasonable, I would say, a reasonable performance. So what we have done is first, performance optimization that we have done is basically bringing in the partition pruning, which allows users, if here is an example wherein two Greenplum clusters are talking to each other through JDBC, just by adding the partition by clause in my table definition. Again, the magic happens when in your PXF profile. Just by adding the partition by clause, what will happen is Greenplum will automatically understand, hey, okay, I don't have to look at the entire data. I need to do now partition pruning. Here's an example of 50 GB of data through JDBC, 70 minutes down to 12 minutes. And this is just by adding the partition by clause in our PXF. Now, that is JDBC, right? Not all the data sources will give us access through JDBC, because if you're talking about terabytes of data, JDBC is not an answer. So what do we do? So PXF, let's say here is an example wherein I'm storing some of my data on MySQL, or it could be on S3. So the example here is MySQL, but this will exactly work the same way with S3, with Hadoop Parquet, with HBase, etc., etc. It will work across the board, right? What we do is we do something called predicate pushdown. For example, if you're running a query wherein you are putting a where clause, the moment you put a where clause, PXF is intelligent enough to say, hey, okay, if I have this table which has got 10 terabytes of data, but I don't need to bring the entire 10 terabytes, I'll probably have to prune it or just bring the data which is relevant to state California here. Where do we support the pushdown predicates? We support pushdown predicates with JDBC, HDFS, S3, S3 select, Hive. So basically, we're pushing down parts of the query down to the external data platforms. So the data movement between the platforms is literally bare minimum. So one of the other features that we have added in PXF is called S3 select. So S3 is becoming a kind of a standard these days as an object store. And we see a lot of customers asking us, hey, I'm going to keep all of my data or historical data on S3. Tell me, how can you help me? So then we say, hey, you don't have to just store the data on S3, and it's an external table. You don't have to load it inside the Greenplum to tell Greenplum that this is an S3 data. No, as long as this data is on S3, Greenplum has access to this data, and we know the metadata, that's it. Rest, everything else is managed by Greenplum. So we have something called S3 select that basically allows us to do a filtering at the S3 level and also increase the performance just by adding S3 select in my PXF profile. I managed to get 4 to 5 times faster performance. It's again, you don't have to do anything. The developer still runs the same query. He is not changing his query. All the magic happens at the PXF profile level. It's a one-off activity, right? So again, one of the things that you have to, it's very important to consider that everything is SQL. You still get the data, whether it's in a Parquet file format or any other format, Avro format. You still see the data as rows and columns. So your users who have written a query, assuming that the data is inside Greenplum, will basically leverage on the same queries. It's just that some of the data is outside, some of the data is inside. Now, we did talk about JDBC partitioning. We did talk about push down predicates and S3 select. So one of the important things is column projection. So since you come from the big data space, since you have seen, I've never seen a query wherein you are saying select star from a large table and that's my report. That's never going to happen. You're never going to see those reports. It's always going to be like 10% of the columns or 20% of the columns. So the moment I run these queries, they say, hey, sum of one column, average of another column, and then group by with some other columns. The moment I do, have a specific column, so PXF does column projections as well, which means it will only fetch the data which is required for those queries. That means it will also narrow down the columnars as well. So just reducing the IO read and write. So where do we support the column projections? With JDBC, HDFS, S3, S3 select, Hive. And so just to summarize, PXF allows us to scale the storage and compute independent of each other. It gives us a tabular view of majority of the heterogeneous data sources which are available out there. It basically it is open source to begin with. It allows us to have data literally anywhere. You can have your data on cloud, and you can actually push some of the queries from on-prem to cloud, right? Again, that may not be a good model for you, but again, it's an option which is available for you. It allows users to have this option of cloud burst, wherein if I'm a user and I just need to have, there is just an end of the year, I just need to get like thousands of reports out. What can I do? If you have data on S3, all you need to do is create Greenplum on containers, and all of these containers, they will just spend them out. They will read the data from S3, again, do the optimization. Once you're done with the reports, you can destroy those containers and save on those infra. So that is where PXF can be very, very helpful. Again, you don't have, it's very important that you do not have to load the data inside Greenplum for PXF to understand. It's always outside. We will be investing a lot heavily into PXF going forward. So thanks a lot. If you need some more information on how PXF works, feel free to drop me a note. And before we before I hand it over to Ivan, I have a quick question for the team. Just on just a second. So the question is, what kind of data do you process, or would you like to process in Greenplum? So I'm just yeah, you can start. And all right, so we got more than 54% of the participation, which is good actually. And one of the things is, I mean, this is quite consistent with the industry trends that people would like to process structured and semi-structured logs and IoT data. I think, yeah, that's what we are seeing. So I'm going to hand it over to Ivan Novick. Ivan, over to you. Thank you.
Thank you very much, Sahil. The next section is a customer interview. The customer is in the USA, and we thought we'd be kind to them and not ask them to stay up late for the interview. So Ivan Novak interviewed them before. So we're going to show you a recording, and then Ivan will be here to answer any questions. I'd just like to share my screen. And Ivan, can you tell us a little bit about the person that you interviewed?
Yeah, this interview is of Ailun Chin. She is leading the operations team for both Greenplum and Postgres at Morgan Stanley. In fact, I think these numbers are out of date. They're up to now about 1,600 servers for Greenplum. And so she has to manage the day-to-day monitoring and ensuring for all the applications in the business that the system is always online and running. She manages a global team across New York, India, Montreal, and a number of other cities. And this interview really tries to drive at what is it that makes her successful, and what makes operations teams successful, and how to think about operations when managing either Greenplum or really in general large mission critical operational systems.
Awesome, thank you very much. Let's see the interview.
And I've got, today we're gonna be doing an interview, and Ailun Chin is on the line. Nice to see you today.
Hey, Ivan, how are you?
Good, how are you?
Good, good. Thanks for having me.
You're welcome. Thanks for joining. So can you give the audience an introduction to about yourself?
Sure. Hi, everyone. Again, hope you're doing very well. My name is Aileen King. I am the Global Operations Head for Greenplum Data Warehouse and Postgres Database at Morgan Stanley.
Thank you. Thank you. So in order to facilitate this, I really wanted to share some of the insights that you've gained by working with Greenplum over the years. And to do that, I wanted to do this in the format of a fictitious exercise where you're taking a role at another company who's running Greenplum, and you're trying to grapple with what they've got going on and to stabilize their system to make it really productive for their customers, their users. So let's imagine that you just joined into this new company and you want to analyze their system. How would you go about looking at their Greenplum setup to understand if it's healthy and if it's operating as expected?
Sure. That's a big question, Ivan. So I would actually break it down to several aspects if I'm going and assess the data health. As an operational DBA, I would review from the infrastructure container perspective first. As operational DBA, we manage. That being said, I would actually leverage the GP Check Perf tool, which is the utility comes from the GPDB software bundle in terms of getting an overview on how the hardware performance from say network read-write rate, disk read-write rate, memory from the bandwidth check to establish a benchmark, and then regularly run it maybe once in a quarter, twice every year to see whether the hardware performance degraded or not, because the hardware really are integrated into the Greenplum plan in terms of stability, availability, as well as performance. So apart from that,
so Aileen, so maybe you're saying that if the GP check perf could show some bad machine after some time.
Exactly. So for a new system, I would always actually run it to establish a good benchmark, and then run it to show, say, after 2 months, after 4 months, to show if there's any outliers. So a bad segment could have a much slower rate comparing to other segment hosts, for instance, or overall degradation comparing to the initial benchmark result.
Okay.
So that's that. And one thing I want to highlight is I would actually evaluate the CPU usage across the segment nodes on, say, production systems overall. I would expect the CPU usage across the segments on a busy production system actually on the pretty high side. For instance, 80%, 85%. As long as the master node is not having much higher CPU usage comparing to the segment nodes.
And we are going to rename the master node to something more sensitive name as well.
Thanks, Ivan. I was going to ask that.
Yeah.
But for that. But yeah, so that's the first kind of criteria or category I would go in and do the assessment. Then the second.
But what would you expect if you saw a CPU across 100 machines averaging to 20%? What would that imply to you only?
So for me, it's an indication the system might not be used efficiently or effectively enough, because Greenplum hosts are designed for powerful analytic queries, large data size. So I would imagine, like, for instance, a 48 core CPU or 24 core CPU, it could handle a lot on the segment nodes. I would definitely review the workflow with the application team just to understand how, and is this the right use case for Greenplum, right? You want to use the system to an extent where from your business ROI perspective, it's efficient and productive to leverage the powerful hardware and the Greenplum software.
Okay. And then was there more you were going to say about the analysis?
Sure. So then the next aspect I would look into, say, from the GPDB software perspective, is I would get some type of availability report, basically an uptime report. So for production system which hosts critical applications, I would actually expect that if not 100%, but at least say 99% of the uptime for critical applications. That's very important. That being said, I would also partner with, again, the application owner there to establish their critical jobs performance SLA so that we have a benchmark there to understand their performance benchmark for a couple of important queries. In addition, as operational DBA, we could have our own quick catalog query, simple catalog query just in the admin DB, schedule it on a regular basis, and generate alert if, say, the runtime of that simple catalog query, for instance, you expect to come back in 1 minute, it's running longer than 10 minutes, you get an alert, you kind of know, oh, there might be something wrong overall in terms of system performance. That being said, I would also leverage the queries history table, build some customized script just to get an average calculation on the historical system matrix like the IO, CPU, or net traffic, again, to establish an average benchmark baseline based on your previous query run performance. And then in case your clients, your end user come to you later on certain performance issue, you can always go back to the average historical benchmark plus the SLA you and the application team define together when reviewing the performance health for the system.
So how many different queries would you run to have a system baseline, and how often would you run those queries?
So it really depends on the application use case. It could be 5, or it could be like less, 2 or 3 typical cases. And it's really, you don't have to run it all the time, right? You can schedule it at either when the application is new, onboarding, you run it when the system is quiet, comparing with probably the other products they might be migrating from and to Greenplum. But the point being, it's like run it at some quiet window. And it's kind of, once you set the baseline, I don't expect you have to keep running the baseline track. You just save the output somewhere.
Okay, and you mentioned you would generate an alert. So what's your overall thought on a strategy for alerts in managing a system? Like, what's the role of alerts, and how do you go about managing alerts?
Sure. So for one, alert is something I rely heavily on as an operational DBA. Basically, it's for your team to be able to support a large-scale Greenplum systems in a scalable way and in a feasible way. For instance, you have 2,000, 3,000 machines with 50 or 100 different systems, couple petabyte user data on it. It's just not scalable or not feasible at all, where you can go in and check each and individual system. So alert in that space is super critical for a more efficient, productive, and effort-saving way when you manage the plant overall. Basically, I would say I don't really have a rule for alerts. I rely on it every day, but one thing, on top of my mind, is that each alert, it has to have an action item, a clear predefined action item. For me, if an alert does not require action item, it's a noise where you can eliminate, because it's just sitting there generating noise, and you open it, close it without action item, but kind of wasted your resource, your effort hours.
So could you see having too many alerts? Is that a danger?
Yes, for sure, but there's not a good thumb of rule in terms of number of alerts. I would say it really comes down to a standard category, I believe, for most of the database data warehouse products for like system, again, this from those particular areas, right? Availability, stability, and also the performance. For availability, you could have like apparently system up or down, segments up or down. And then for performance, you could have your own benchmark DBA query or long running query based on, say, a specific application name, user ID, things like that, or blocking. So there's really, I think, a standard things you're looking at if you focus on stability, availability, and then the performance. But yeah, like, in terms of the number, I don't think you should have a lot of alerts. Again, I'm speaking from like a level 3, like assume my team is a level 3 data operation team. A lot of the time, or most of the time, our day-to-day role not include actually looking at each and every single alert. One being we try to automate the action item wherever we can when there's an alert being triggered. Two quick examples. One being, say, if you have a catalog table bloat and you generate an alert based on your own predefined threshold of the bloat percentage, instead of just generating alert, I would consider automate the follow-up action in terms of running an online vacuum and analyze job as part of the alert triggering, so that you don't even need to worry about the alert in terms of action item, right? And then the second quick example could be, say you have a failing disk, let's say, and then there's some alert being generated when it's host level, and instead of you going and then check, you could kind of automate some kind of ticketing submit to your internal Unix hardware colleague for further looking into. But yeah, these are the first two examples in terms of reducing the number of alerts, and two being really anything that's a particular alert. In terms of action item, it's a predefined procedure, right? Where I would expect the standardized procedure could be easily transferred across different level of teams. So Ivan.
So yeah, there's two things you mentioned there I want to double click on. One was automation. So how important would you say automation is to your role, and how often do you try and do automation to improve the system then?
Yeah, sure. So automation is my top priority, my team's priority, top priority in our day-to-day job. Every day, the top task on my list is kind of, oh, okay, is there any area for automation for level 3 or for level 1 team, right? So some of the examples we are doing, let's see the patch upgrade, because major upgrade, we are so super excited about that new GP upgrade tool that Nirali and Randy gave the presentation for. But let's say for the patch upgrade, it's a straightforward upgrade. However, given the scale of most of the Greenplum systems large company could have, like again, 50, 100, you have like thousands of end users, then what would happen is that instead of having, say, a DBA team member to going open 100 different putty window and doing the patch upgrade itself, I would push for an Ansible playbook approach, for instance, where you can just pass the parameter of the systems and then you get to upgrade, say, 100 systems at one time in one shot. So that's just one of the many automation opportunities you can looking at, and I do feel this is like, just I cannot emphasize more on the priority in terms of the automation itself, Ivan.
Got it. So, and you mentioned level 1, level 3, ops team, DBA. So if you were the consultant and you're coming into this mega corporation running Greenplum, how would you set up the team structure? Like what are the different layers and teams you need to look after the application and the database and the infrastructure? Like how would you organize teams to manage all that if you were coming to a new company?
Yeah, sure. So I would look from resource perspective, I would probably sit down with the existing, like the level 3 team to understand their workload, including work days, including weekends, because as DBA, we all know on weekends, sometimes we're even more busier comparing to weekdays based on, the business hours. Application usage could be very active, and a lot of maintenance work windows has to be on weekends. That being said, it's like a workload balance. If, say, there is one on-call team member from one time zone region, right, being North America, being Europe, being Asia, and apparently if they're very much overloaded, and I would break down into, oh, okay, what are your time spent at? How much time you spend on watching alert? How much time you spend on responding to alerts? How much time you spend on, say, a maintenance window? So far, so and also say, for instance, how much time you spend on consulting for your clients on a more comprehensive performance and tuning or incident management troubleshooting on a production system. So that being said, you will have a very clear picture once you break down the time that the resource is spending on like a particular day of the time or like on a weekly, weekend basis. That being said, for standard tasks, like anything, there's no kind of like outside of the box ad hoc procedure you have to add on. If it's a standard thing, like you got an say bloat alert, for instance, it's standard procedure, right? You go in, you check, oh, okay, it's beyond certain percentage, and the action would be vacuum and analyze the catalog table. So anything that can be predefined, I would ideally get that into a level 1, let's say, procedure for starting from alert monitoring, because it's just more efficiently you have that segregation where someone purely watching the alerts and then follow a predefined procedure for each and every alert, and then escalate to the next level of team when they can't solve the problem based on the predefined procedure. So that the level 3 can focus on automation, on major incident troubleshooting, on a lot of performance and tuning consultation, or say design review, architecture review with the end user, the clients.
And then is there, so then that's ops, and then would you have another team called like DBA team, or is ops basically doing everything?
Not doing everything, right? Let's say assume you're not cloudy yet, right?
Yeah.
I would assume that most of your hardwares are still managed by like on-premise, right, in your company. So there has to be, based on the on-premise assumption, there has to be this dedicated data center or hardware group who are the expertise to manage for anything from host level, right? It's just not, it doesn't make sense that DBA also owns, for instance, managing the firmware version on each and every disk on each and every host, right? So it makes sense that, again, the assumption is you have an on-premise hardware scope in your data center footprint. This hardware team is a very important partner that you work closely with for anything related to the hardware stability, again, availability, performance. And then you apparently have most of the, I believe, the corporation would have an engineer team in addition to the ops/DBA team, right? Where they bring in, for instance, the Greenplum, the Postgres tool, and then they engineered it. In our world, we organized it to make sure we have all the requirements for the company security review, risk review, and also tailored to our company and clients' need. So there will be different teams. It won't be one team supporting all. Again, it's just more efficient that way, where you have clearly your end user client, you have your the engineer partner, and your ops/DBA team with the hardware colleagues who manage anything related to the host.
Okay. So, so let's say, again, at mega corporation, a new corporation you're working at, would you expect Greenplum to be the only database, or how many different database technologies would you expect or would be reasonable for a major corporation to manage? And how often would you think you would bring on a new technology or phase out an old technology?
No, answer is definitely no to one technology only. Have to bring in Morgan Stanley a little bit, right? For us, because our end user from different business units, they are very tech savvy. They keep looking for cutting edge new technology on the shelf. A lot of times they bring in the new ideas or the proposals of a new type of technology in terms of data, right? All different type of data products pretty much on the shelf. They would evaluate, again, the key point is based on their use case, based on cost. And a lot of focus nowadays could be, is it cloud integration ready for the next generation migration? So that being said, it's definitely not one database product. It would be really vary. I don't have a magical number in terms of what's the best number of products you maintain in your corporate. It really varies based on how fast can you test, certify that new technology and provision it to your end user, right? It could be something newer coming up and you just still are in the phase of certifying that technology to meet all the security needs or your client's needs. So it comes down to how efficient you can do that, as well as the use case. Really, that's the key. For instance, let's say if there's a database usage for 2 GB data, or say 1 terabyte data, we would not recommend that user to use Greenplum, right? If you have, say, 50 terabytes more, that's definitely a good use case on Greenplum, just a very brief example. But yeah, the key point really is how fast you can introduce the new technology, certify it, the cost, right, associated, and then the critical use case is whether the product is suitable for the end user use case, Ivan.
Right. Okay, so for the new Greenplum administrators and operations folks who are on the call, any final advice that you would give to them as they start their role managing Greenplum? Is there any tips or overall advice you'd give them for how to be successful that you want to share?
Sure. Thanks for claiming me as successful. I would say, I think, Ivan, you already covered the most important one, which is the automation. So automation is what me and my team would think every day in terms of looking for area that we can further automate. So the second, I would say, is more of like mindset wise, to be very proactive. I really personally, and my team, we don't like it where it has to be passively reacting to a user problem after they hit the performance impact or they hit an issue and they come to us to report. We would try everything to be proactive in terms of identify the problem before it's actually causing an impact to our business user. One of the examples being, again, hardware still, it's a critical component integrated with the overall Greenplum plant performance, stability, availability. So we would kind of like say, oh, okay, not only from a Verilog message error to see there's actually a disk already in failed status, we will look for a trend in terms of, oh, how many total media error count this particular host already have since the past week or so. And we predefine a threshold. Let's say, oh, this host has more than 1,000 media error, although it's not in failing status yet, but we know there might be a chance, highly likely the host could fail. Then we take proactive action by getting that alert and the reaction being, oh, check that host and get that host out of rotation before user hit a slow performance due to a failing disk. So that's one of the example, but it's a continuous tough task where we look every day in terms of the mindset of being very proactive. And then the last thing I think is, for any job, you have to love your job, you have to have passion about it. That's when and where you can go above and beyond for whatever role you're taking, Ivan.
I think if people followed your advice, they could be successful in any operational role with any technology, even outside of technology. If people were managing a train system, then doing those advice would be good, right? So, Alan, thank you so much for your interview and for sharing your insights. I think the customers out there who are just getting started are going to really appreciate that. Thank you so much. And
thank you very much, Ivan.
welcome.
Thank you very much to Eileen, even though she is not here to accept our thanks, but that's a fantastic interview. 1,600 servers, 20 odd petabytes of data.
And in terms of cores, it's some 40,000 cores.
And she obviously loves her job.
Yep.
And I think I think that's a testament to what Greenplum can do for her, because if we were making her life hell, she wouldn't be enjoying her job, and she certainly wouldn't be giving such a positive reviews in the interviews. So thank you, Eileen. Before we move on, I have one question that I would like to ask everyone. I'd like to know, how did you find out about this summit? Did you find out from a friend? Did you find out from a personal invitation? Did you get a invitation from VMware? Or did you just see it on the web? Okay, the VMware invitations look to be working. I'll have to say thank you to our friends at VMware. I think we have a clear winner here. Thank you very much, folks. Right. The next presenter is going to be Jimmy Chu. Jimmy is going to take us through the command center, part of the commercial extensions for Greenplum, something that I'm sure Morgan Stanley used to keep their systems under control. So Jimmy, take it away, please, mate.
Okay, hello everyone. My name is Jimmy Chu. I'm supporting ANZ and Taiwan pre-sale activities. Today I'm going to show you how do we use Greenplum Command Center for database monitoring and management. Also, I'm going to show you the latest cool features around the resource controls. For today, here's the agenda. Let's begin with the introduction of the Greenplum Command Center. Then I'm going to present some the latest features around workload management. I will also explain why workload management is important and what have we done for this. At the end, I'm going to play some demo video for you to show you how to use Greenplum new workload features. For my 12 years with Greenplum, I'm always got this question from customer. Even Morgan Stanley have shown this, right? How do we do database monitoring and management? After selected Greenplum, the data operation has become important task. Customers need to monitor and management workload, while be aware of the system status, such as hardware labels, software label, database, or even user labels. Greenplum Command Center, or known as GPCC, is a web-based browser tool come with commercial Greenplum distributions. It gives the DBA an easy way to view the system status and to management database activities. In the recent years, we have enhanced GPCC by adding intelligence to allow automation process and loop-based controls. Our vision is to have GPCC the go-to place for all the Greenplum monitoring and management activities. Before I continue, let's do a quick polling questions. Are you currently using command centers for your Greenplum database? Okay, we can see a quite even number. So it's a 50-50 now. So we are reached to 37%.
All right, Jimmy, we have crossed 48%.
Yep. Okay.
Yeah, 50%. Yeah, I think, yeah, it's 50-50 almost.
Yep, it's 50-50 almost. Okay. So we do have some new customers and some, old customers are joining this WebEx. So if you are not familiar with GPCC, right? After you log in, there's a dashboard for system status summary and a sidebar. And on the sidebar, there are many tabs to show the class label, node label, and query label information. GPCC also store historical data for you to search or explore as report later on. GPCC also provides some admin functions, including setup alerts, which Morgan Stanley has mentioned. How do we set up alert and using that to set up action items? And we can set alerts when system usage is high or reach to a certain point. So you can click on the admin tabs and set up alert based on those 4 labels. class label, master label, segments, and query labels, and set the value to be monitored in terms of minutes or percentage. Once you're done that, you probably want to know like what is running in the database now. So you can go to the query monitor tabs. It shows the current queries. This page gives you the details of running queries, query in queues, or query blocked. You can even select a query to be terminated on this page. Or you can draw down further by moving your mouse to the highlighted query IDs. Once you move your mouse to the ID and click on, you will see the full SQL statement and execution plan. And you can do a full screen on the execution plan. You will show the real-time action plan and display cost and running time for each motions. On the performance area on the top right-hand side, you will find information such as CPU memory usage and the number of spill files. Those information are very good to determine if the query hit the CPU bound or IO bounds issues. Okay, in the recent years, we actually deliver 3 new features. First, a table browser. This tab shows table metadata, including last access time for each tables. Secondly, recommendation. You can use this tab to get a report on maintenance job needed. You can even use this page to schedule to run your maintenance jobs or find table skill. Lastly, the workload management tabs for system resource controls. So let's look at the latest feature in details. Why do DBA need these features? Or put in other words, what benefit can this bring to the table? In the past years, we have learned about how DBA manage their workload and what challenges they are facing today. To start with, right, every day they need to make sure the system is healthy and all the jobs have to be complete in time. Whether this is to generate reports or to optimize for long-run queries. But most often, there is a congested database filled with all kinds of queries. Some of them are taking too much resources, which result in long delay of getting results or delay in ETL process. So they will probably need to find a way to prioritize urgent requests and make sure they actually complete ahead of time. This requires a flexible resource management tool, especially during the rush hours. So how do we tackle those challenges? We are using resource group and workload manager to solve these issues. Resource group is a new resource manager in GP5 and 6. Similarly to the resource queue within GPDB 4.3, you can use this to control the resource limit on queries. It controls the concurrency on the transaction labels. Our resource group is based on Linux C technologies. It can guarantee the CPU usage isolation by certain percentage of values. This resource group also provides the memory isolation. All of that give a better workload management compared to the legacy resource queue within GP 4.3. With GPCC, you can route your important queries to a group that have allocated sufficient resources, so the query can be complete in time. For those less important or non-time critical queries, you can move it to a less. You can move them to a queue with less resources. Or you can create loops by moving queries to another resource queue while running. If you want to accelerate some of the queries, simply move a query to a group that have more resources. Or to release a resource, simply move out a query from a group and give to a less resource groups. After set this up, this is auto apply. Or if you want to do this manually, go to the query monitor tabs. Besides moving queries, you can also set up loops to abort queries to prevent them using too much resources. You can define loops to cancel queries according to their CPU time, plain cost, slice number, and running time on this IO consumption. So let me show you some demo right now. The demo I'm going to play, the first demo I'm going to play is how to use resource group to prioritize queries.
If you have used resource queue before, GPCC can help you import the resource queues to resource groups. The previous ad hoc queue will be imported as ad hoc group. You need to specify the concurrency, CPU, and memory limit for each group on this page. It will take some time to import, and you will land on this page. This is the page to manage all your resource groups. You can add a new resource group here. You need to specify all these metrics. The CPU limit and memory limit cannot exceed 100%. Other than that, the settings should be dependent on your requirement. The more CPU and memory you assign to a group, the faster the queries will be processed. The statement memory indicates the amount of memory that a query can use. It is calculated from a formula using the group memory limit and memory speed ratio. You can also edit this resource group to make changes. In the second half, you can assign roles to a particular group from this page so that their queries will only run in the assigned group. For example, add a GPMon to the test group. Just type in the name and hit enter.
Okay, so the second video, I'm going to show you how to create a rule to move queries to another resource group or to above queries.
When you're new to workload management, you will see this landing page. Click Create a New Rule, and you enter the process. First, choose the identifiers. By default, the new rule will apply to all resource groups. You can change it to apply to a specific resource group, like default group. You can add other identifiers, including query tags and roles. If you don't want more options, simply delete it. In the second step, choose the conditions. Here are all the options. Let's choose CPU time. We want it to be more than 60 seconds. In step 3, choose an action. We can move this to other resource group, and then we will choose the destination resource group. Now the rule has been created. You can view it on this page. Next, we are going to create a rule to cancel the queries. We'll apply this to all resource groups. In the conditions, we can choose disk I/O when it is more than 200 megabytes. We can add a new condition as well. Say, set the running time to be more than 10 minutes. In action, we can choose Cancel Query and hit Create. This is another rule. You can create rules based on your use cases or scenarios.
Okay, if you want to do this manually, you can go to the query monitor and adjust it by selecting a different workload. This is useful when you want to speed up a long-run query or by giving a higher value of the CPU or memory limits. Okay, now you must be excited for this new feature of GPCC. You can download GPCC in the VMware Tanzu network website and try it out yourself. Thank you for joining today's sessions. If you got any questions, feel free to reach out.
All right. Hey, thank you, Jimmy, for that wonderful session on Greenplum Command Center and how it can be used to monitor, operate, and manage Greenplum clusters. If there aren't any additional questions from the chat window, I think we'll move on to the next session. I'm actually going to be giving the next session. My name is Wu. I'm currently part of the Tanzu data science team. And what we'll do is we'll spend the next 15 minutes on generating insights with advanced text processing with a tool called GP Text on Greenplum. All right, so listed here is the agenda for today's session. We'll start with some background and context to set the stage for the reasons why and how GP text can help organizations generate insights from text data. We demonstrate this with the case study, which illustrates how GP text was used for a major financial services company. And then we'll close the session with some pointers on how to get started with this tool. But before we begin, I wanted to ask a couple of questions to you all to understand where you're coming from in terms of your journey with text analytics with or without GP text. And so Sahil, if you'll do the honors of sending out the poll, please. Thank you. And so, yeah, there's 3 questions listed on here. The first one is whether your organization is collecting unstructured data today. And if so, how much of that unstructured data is being analyzed? And then last but not least, if you've explored the use of GP text for those workflows. All right. Looks like we got a couple more trickling in. Give it a few more seconds.
你们可以说话，没关系，我爸已经讲完了。
All right, I guess we'll call it there. In terms of the first question, I know a couple of you are still voting. Sounds like most of you are collecting unstructured text data today. And unfortunately, kind of like what we're seeing with most of our clients, a lot of that data currently isn't being analyzed, right? About 10% or less, right? And then for the vast majority of you, about 88%, you haven't yet explored the use of GP text to analyze that unstructured data. So that's great because hopefully some of the things that we'll talk about in this session around GP text and how it can help you on this unstructured text analytics journey will help you get started on that front. Now, there are a lot of different viewpoints on the scale and the coverage of text analytics data today, right? This is one estimate from the Chief Analytic Officer of FICO, who estimates that the vast majority, just like we saw in the poll, of the world's data is unstructured, right? 80 to 90%, and that less than 1% of that data is effectively analyzed. He also highlights the importance of access to the right set of tools to productively mine insights from this vast unstructured data. And like I was saying earlier in this session, I'd like to share why I believe GP text on Greenplum is precisely that right tool for text analytics at scale. GP text is part of a broader ecosystem of analytical tools that integrate natively with Greenplum. This ecosystem of products supports a wide variety of different tasks and procedures for data science development in a unified and cohesive single platform, right? Like I said, there's a lot of different tools here, Apache Madlib and PL Container for parallel Python and R, are some examples of tools that would fit in the machine learning and deep learning category. We'll focus on GP text for this particular presentation, but I encourage you to check out our other sessions in both, this run of GP Summit in November and also in December that will provide you with some walkthroughs of the other groups of tools that are listed here. At a high level, GP text is a module in Greenplum which allows users to easily index and search for textual documents, right? And the way to think about this is ask yourself the question of how do you look for topics in a very large and long and heavy book? One way to do this is to go to the index pages, right, at the back of the book, at the end of the book, which point you to specific pages in the book containing information about your topic of interest, right? And in sort of the same way, GP text can extract information from a wide range of different formats, and it will then organize this textual information into an index, which provides sort of a metadata, which easily enables you to search for these textual files for information of interest. It's a parallelized and distributed implementation of Apache Solr and makes fast information retrieval possible on big data when combined with Greenplum. So now let's get a little bit more specific on when you need GP text, right? And in a nutshell, the guiding principle here is to use GP text when you have a bunch of unstructured data and you're not sure how to analyze it with the traditional database. I've outlined sort of 3 key needs that GP text aims to address from a persona perspective, right? And a scenario perspective. We'll start with the first one. Using GP text when you need access and want to analyze textual data from anywhere, right? This tool, it supports data that's stored on really any file format. It can be in document format, in CSVs, in HTMLs, and PDFs, etc. And it also supports data that's stored anywhere. It can be inside of Greenplum. It could be in HDFS and S3, HTTP, really what have you. It's really being able to ingest and analyze a whole wide range of unstructured textual data, bringing that into GP text with high availability. This is kind of the key differentiator of what this tool offers, right? It also increases, the amount of information that can be leveraged to support decision making and improve business outcomes at large, right? So it's able to pull in that data from a variety of different sources, no matter what format you have that data in. The second differentiator of GP text is being able to use this data from a variety of different sources and also do flexible searches on that information, right? This is functionality that you might expect from a user experience perspective on search engines like Google, right? Imagine that you can also do keyword search along with more advanced search capabilities like fuzzy search, fuzzy matching, and faceted search for grouping search results together, right? These are all made possible with GP text, and we'll show you what this looks like in the next slide. So this is an example of a real input query and the resulting output that you get back from GP text. The set of documents in this example are Wikipedia articles, right? And the input query here on the left-hand side, it asks GP text to search for Wikipedia articles that contain the following terms: solar and battery, right? What you see on the right-hand side with the partial output, it lists the Wikipedia articles and their titles that are most relevant to those keywords, solar and battery, right? And when you take a look at the results, it makes sense to see that the Wikipedia article titled solar power shows up at the top of the list for a query on the search terms for solar and battery, right? This is one really basic example of the core search capabilities of GP text, but it really just scratches the surface. Additional flexibility in search is supported through tooling, including wildcard searches, proximity searches, and faceted searches to aggregate and summarize search results of interest. And then last but not least, you can also use GP text and expand its core search capabilities to include in your pipelines for advanced natural language processing. Stemming, tokenization, these are all things that are possible with GP text. In today's session, we'll focus on something called named entity recognition. And it's actually best explained through an example. So in the quote that you see here, it's able to recognize, right? This named entity recognition module is able to recognize that Apple and Flint Center are organizations, that Tim Cook is a person, and that Cupertino is a location, right? And so the user can ask GP text to find all the organizations in a set of text. And in this example, it will return 2 things: Apple and Flint Center, right? And the other thing to note here is that through this module, the NER module, GP text is able to recognize the fact that Apple in this context is not the fruit, but the name of the company. It's able to do that correctly. So we've walked you through some core capabilities of GP text, and we'll now spend the remainder of the time on how these features can be applied to business use cases. Just like Greenplum itself, GP text can be used for a wide range of different applications across multiple verticals. Today, we'll focus on how GP text and Greenplum were used in financial services by one of the largest investment banks in the world. This was a global investment bank who wanted to improve the efficiency of its algorithmic trading system, right? And as many of you know, algorithmic trading works by making use of a computer program which follows a set of instructions. We call this the algorithm, right? To systematically place trades at speeds and frequencies that no human can match. And by adopting these algorithms, these trading systems are able to reach a level of profitability that's impossible for humans to match without them. You see one example here of an example algorithm. Maybe the rule here could be, hey, sell 100 shares of stock when its 50-day moving average falls below the 200-day average. And that could be an example of a very simple one that you'd want to include in your trading system. To take a look at the data that this bank was collecting, it had information about financial information exchange logs, or FIX logs for short. The FIX logs contain information about trades and all the corresponding algorithms that were used in support of that trade, right? And the main goal here was to index and search the FIX data and identify the algorithms that were rarely used, because these are the specific algorithms that were not meeting user requirements, right? And if you know which ones were rarely used, you can then make improvements to these algorithms so that you can increase the profitability and productivity of the trading system at large. In the next slide, we'll actually spend a little bit of time describing what these FIX logs look like in terms of the raw data, right? So we won't go into too many details here. You can think of FIX logs as having an identifier in terms of the record number, and then also a bunch of what are called tags. And tags are kind of like what you'd see in a typical relational database column, right? Each FIX record or message describes information on one trade and consists of many tags that provide characteristics of that particular trade record, right? And in the context of our use case, along with things like, let's say, the price of that trade execution and the transaction time in which that order was executed, we also had information on which specific algorithm was used for that trade. So here are some key challenges that the client was facing. First of all, there are tens of thousands of tags in the FIX logs, and it's not easy to treat them as regular unstructured data, right? Secondly, not only do we have wide data in terms of tens and thousands of tags, we also had very long data. So hundreds of billions of fixed messages, which was too slow to run on a traditional database. And then lastly, there was also a functional requirement to be able to search on these hundreds of billions of fixed messages, and doing so on a relational database would just be too slow. And this is where now the prospect of using Greenplum and GP text really came into the picture. So we'll start with our solution, right? So we started by ingesting all of this fixed data into one column of a Greenplum table. And rather than having to create tens of thousands of columns and indices to do this, we only needed one single GP text index. And that helped quite a bit in terms of parsimony and being able to be really efficient about storage and execution. Secondly, we then parsed the fixed messages with tokenizers and filters. And then we built the GP text index to organize all the information that were contained in these fixed logs, right? In the context of this particular use case, searches were then made on that index to search for particular algorithms that were the most rarely used and the ones that could be flagged for further investigation and studying to improve the quality of those algorithms, right? And not only were we able to identify those algorithms, but we were also able to join GP text to additional search results that you got back in Greenplum for enrichment, right? So you could, for example, build a machine learning model on that combined search result to find patterns in the underutilized trading algorithms, kind of the root causes for why a particular algorithm was really used in history. So to wrap up, with the adoption of GP text, this customer saw a 50-fold gain in performance to identify underutilized algorithms in their trading systems, right? These algorithms were then examined so that improvements could be made to them to increase usage and profitability. The success of GP text was one of the reasons why this particular customer expanded its Greenplum footprint to petabyte scale. And the usage of the platform has now spread to other areas of the bank, including capital allocation, wealth management, and liquidity analysis. With the summary of that case study, this wraps up the main content for my session. If any of this sounded interesting to you and you're looking for ways to get started, we offer some guidance and advice on this slide. The main suggestion here is to start small and dynamically grow your usage of GP text after the value of this tool as an NLP engine is realized firsthand. Right? You can install and expand GP text quite easily, especially if you're familiar with doing that and how to do that on Greenplum. And then, of course, it goes without saying that the Tanzu data team is always available to help you. So please don't hesitate to reach out if you need any support or guidance along the way. And with that last slide, I truly want to thank you again for your precious time. And I hope you found this session helpful. Right? I've shared my contact information here in case you'd like to reach out after the conference with any additional questions. So please do that. And thanks again. Take care.
Thank you very much, Wu. I'd like to say thank you to everyone that has stuck with us for the 2 hours. It's good to see that we lost, I think, 5 people, which is an amazing effort to keep everyone engaged and interested. I'd especially like to thank everyone that was asking questions on the chat. We got some good feedback and some good questions. This is the first of 2 sessions. We have another session coming on December the 3rd, where the highlight will be Ivan Novik going through the Greenplum 7 roadmap. I'd like to thank Ivan and Jacques for staying up well into their night to support us on this event. And thank you very much, everyone. I look forward to seeing you all on December the 3rd.
Thank you, guys.
Thank you, everyone.